Assalamualaikum and good evening to Dr. Zamri and my fellow friends. Today we from Group 5 will be presenting about how to treat this wastewater. So this is our members, which consists of 6 members. I'll start the presentation with an introduction. So wastewater is known as a contaminated water that results from human activity, and usually it's being discarded by household and manufacturing plant. And before are being recycled or being transferred into natural bodies like seas, rivers, and lakes, it will be treated beforehand to remove all the contaminants. So the wastewater treatment is known to be able to remove physical, chemical, and also biological pollutants. So these are the type of waste that commonly found in wastewater. In this presentation, we will be focusing on how to remove all these 4 types of waste, which is color pigments, protein, blood, and heavy metals such as mercury and lead.
The first wastewater that we will present is color pigments. Did you know only 4% of the total water used in the production of paint is recycled worldwide? At nearly 70% of the total wastewater is discharged untreated, and 25% is not discharged but disposed by the evaporation or some other method. So where we can find these pigments, firstly in the skincare or makeup, which consists of iron oxide and chromium oxide. Secondly is paints, which contains titanium oxide and anthraquinone. And lastly, from the dyes of our t-shirt, for example, azobenzene, xanthine, and tryphenylmethane. Now, the treatment of these color pigments is divided into 3 sections. So, the first section is primary treatment. Primary treatment is consists of removal solids, excessive quantities of oils, grease, and gritty materials. Other than that, by using bar screens and fine screens, can remove the coarse suspended materials such as yarns, lint, fabrics, and rags. The second treatment that can be remove color pigments is coagulation. Coagulation is a type of chemical water treatment that manipulate the electrostatic charges from negative to neutral of particles suspended in water. It is used because it is simple, can handle large concentration, and also found to be less expensive. Selecting the right coagulant for a system will enhance the overall performance and particularly improve solid removal efficiency by enhancing filter and clarifier performance. Also, by using biocoagulant that are made from plants are found to be eco-friendly and practically suitable for wastewater treatment. The suspension of solids in the water typically contains a variety of sizes. The larger the diameter of particles, the less settling time for the solids to be removed. Another type of secondary treatment is biological treatment. The process is considered to be inexpensive, eco-friendly, and also an economical solution for degrading the wastewater, especially water that containing dyes. The biological substances has the ability to convert the pollutants into waste, carbon dioxide, and salts, which are inorganic to nature. Example of biological treatments consist of fungal decolorization, microbial degradation, and adsorption. Algae also plays a major role in removing the pollutants from the aqueous solution. They are categorized based on the color, colloid content, and the performance of algae selection depends on the bioabsorption capacity and affinity.
Now on to tertiary treatment. The tertiary treatment process is for the final removal and purification of the wastewater. The purpose of tertiary treatment is to provide the last treatment stage to raise the effluent quality before it is discharged to the receiving environment, such as the river, sea, or lakes. It is also done to raise the treated water quality to a level to make it suitable for intended reuse. This phase eliminates various pollutants that secondary treatment is unable to. and through the employment of stronger and more advanced treatment systems, the wastewater effluent is made even cleaner during this tertiary treatment process. Tertiary treatment involves segregation techniques that separate dye pollutants via multiple physical methods, such as adsorption and filtration. The traditional water purification methods, like ion exchange and absorption over activated carbon and other low-cost absorbents, have been proved to be very effective decolorization methods. In the case of ion exchange, it is the ionic charge that will allow differences between some ions and others to be established. For example, if a particular contaminant is cationic, it will exchange ions with cations, which are positively charged ions, without interacting with anions, which are negatively charged ions. Absorption, on the other hand, is a process where a solid is used for removing a soluble substance from the water. During wastewater filtration through activated carbon, the solid is the activated carbon, and the contaminants will adhere to the surface of these carbon granules or become trapped in the small pores of the activated carbon. There are other techniques that can be done during the tertiary treatment, and this includes nitrification and denitrification. Nitrification is a biological process that converts ammonia to nitrate and nitrate to nitrate. Additionally, if standards require that the nitrate needs to be removed, the denitrification process is done, which reduces nitrate to nitrogen gas. Membrane processes are another technique that are essentially advanced filtration processes that utilize the separation properties of finely porous polymeric or inorganic films, and they can be classified into several sub-processes such as electrodialysis, microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. In the case of electrodialysis, the application of an electrical potential will provide the driving force for the separation. Microfiltration, ultrafiltration, and nanofiltration will make use of the size difference between the particles to be separated and the pore size of the membrane. However, this is not the case for reverse osmosis, which is a technique based on the different diffusion or permeability of substances when crossing a membrane. Thus, although a solvent may permeate the membrane easily, suspended particles and those dissolved in the solvent find it very difficult to pass the same membrane. Aniline polymerization is a process that is done to treat wastewater as well. Aniline has been widely used as a raw material or intermediate in the synthesis of organic compounds, and a high concentration of aniline is present in wastewaters with dye and pigments in it. The aniline is responsible for the high chemical oxygen demand and electrical conductivity values in wastewater. This is because the aniline polymers themselves are electrically conductive, and hence a higher value of electrical conductivity in a wastewater will denote their presence. To treat this, aniline is best polymerized by ferric chloride in acidic conditions.
Moving on to the treatment methods used in treating protein from wastewater. There are a variety of sources in which protein can be found in the wastewater, mainly the soybean processing, milk processing, and also the potato processing. The first treatment used in treating protein from wastewater is the ultrafiltration. In ultrafiltration, solidification is done as it removes large particles such as starch and fibers from the wastewater. Next, sedimentation is done for 4 hours. And then it is followed by filtration using filter paper, which helps in removing insoluble and soluble starch and fiber from wastewater, and also substances with a size in the micrometer range. And lastly, ultrafiltration is done by polysulfone membrane, as the retentate of membrane filtration is reached in the desired protein. So, why treatments are done during the before ultrafiltration is carried out is because the transmembrane pressure increases suddenly due to concentration polarization, which lead to the cake layer formation and pore blocking process. Hence, by doing this pre-treatment, it can help in reducing the formation of cake layer. Next, we have the anaerobic baffle reactor, or ABR. So in anaerobic baffle reactor, it is a series of vertical baffles containing large active microbial mass which are arranged to force the wastewater to flow under and over or through the baffles covering the full surface of baffles, which enables contact between influent wastewater and biomass. So these simple low-cost construction, these simple and low-cost reactors are highly stable to shock loads, both hydraulic and organic, which provide high void volume with low clogging due to reduced sludge generation because of high sludge retention times and low hydraulic retention times. And the advantages of using ABR is that there's no special gas or sludge separation. It has a lower sludge generation. It has a long biomass retention times and also low hydraulic retention time and high stability to organic and hydraulic shock loads.
So now I'll be talking about how to treat water waste management contaminated with blood. Firstly, the source of blood in water waste are abattoir and animal processing factories such as bovine, poultry, and fish. So here are the treatment of water contaminated with blood. The discharge require a reduction of suspended solid, measured as total suspended solid and biological oxygen demand. Next, reduction of biological oxygen demand and chemical oxygen demand. And lastly, disinfection of pathogens and other harmful agents. Here are the list of technology used to treat blood wastewater. Firstly, we have anaerobic sequencing batch reactor. Secondly, we have hybrid outflow anaerobic sludge blanket reactor. Thirdly, we have fixed batch sequencing batch reactor. Fourthly, we have anaerobic treatment in an outflow anaerobic sludge blanket reactor and in anaerobic filter. Fifthly, we have moving batch sequencing batch reactor. Sixthly, we have anaerobic hybrid reactor, was packed with lightweight and floating media. And lastly, we have chemical coagulation and electrocoagulation techniques. So that's all from me. Thank you.
Next, I will explain about the last contaminants, which is heavy metals. Firstly, heavy metal can come from various sources, such as industrial waste, agricultural activity due to the usage of fertilizer that contains heavy metals, household wastage, and lastly, landfill leachates. Therefore, there are many types of treatments that can be conducted to remove heavy metals from wastewater. However, in this video, I will be explaining about 3 types of treatment that can be used, which are chemical precipitation, membrane filtration, and also coagulation and flocculation. Let's go to the first one, which is chemical precipitation. Chemical precipitation is a process of leading heavy metals that are dissolved or suspended in a solution to form a solid precipitate, which can later be separated by sedimentation or filtration. There are 2 types of chemical precipitation that are usually conducted, which are hydroxide precipitation and sulfide precipitation. Hydroxide precipitation can be referred as a process of converting heavy metal ions to a heavy metal compounds, which by the addition of hydroxide. However, the precipitation process can be affected by the metal concentration and also the pH of water. For sulfide precipitation, it has a more complete removal of heavy metals compared to hydroxide precipitation, and it also resulting in less sludge quantity and also easier dehydration. Next, membrane filtration. Membrane filtration has been known not only capable to remove organic compounds and suspended solid, but it also can remove inorganic contaminants such as heavy metals. Membrane filtration has been known to have a different types of membrane with a different pore size of range, which can later remove different various sizes of contaminants. For example, the types of membrane filtration that can be used to remove heavy metals are nanofiltration, reverse osmosis, and ultrafiltration. For example, nanofiltration has been known to effectively eliminate nickel, cadmium, copper, and arsenic. And for reverse osmosis that uses a semi-permeable membrane, it only allows purified fluid to pass through, which can later separate the pollutants, which are heavy metals. Lastly, coagulation and flocculation has been used to treat wastewater in removing heavy metal contaminants. Coagulation is the destabilization of colloids by neutralizing the forces that keep them apart. The example of coagulants that are usually used are aluminium and ferrous sulfate. For flocculation, it is the use of polymer to form links between the flocks and bind the particles to form a large aggregate. The suspended particle will flocculate and later can be detached by filtration, flotation, and straining process. Coagulation and flocculation will require a sedimentation and filtration to collect foam.
As a conclusion, wastewater treatment is a crucial process in ensuring a good, clean and safe water supply for communities. And with the advanced technologies, wastewater treatment is able to remove a wide range of pollutants and contaminants by using different types of mechanisms. So I think that's all from my group. Thank you for your attention.